Thank you. Thank you. Thank you for your confirmation. So shall we continue, students? Okay. Okay. So welcome you back. Uh, Now I'm just going to present a video about Industry 4. So in order to make you more and more aligned about the factory automation, you will learn a lot of things in this video only. And I'm just going to ask you few questions related to this video. That what you understood by that, okay? And what kind of knowledge purview you are going to get from this video, okay? Just look to that video. If there is any issue uh, of buffering or not clear voice, then you can just unmute yourself and respond, okay? So is it visible? Is the tab visible to you? Yeah. Okay, so I'm going to continue with this.
Manufacturing product. Vision of tomorrow's manufacturing. Products finding their way independently through the production process. In intelligent factories, machines and products communicate with each other, cooperatively driving production. Raw materials and machines are interconnected within an Internet of Things. The objective, highly flexible, individualized and resource-friendly mass production. That is the vision for the fourth industrial revolution. A look back at history. At the end of the 18th century, the first steam engines and the intelligent use of hydropower revolutionized production. The late 19th century saw the rise of electrical engineering and mass production. The first moving belt conveyor was used as long ago as 1870 in the slaughterhouses of Cincinnati, Ohio. In the mid-1970s, electronics and IT began to expand rapidly into industry. Siemens developed the first Simatic. Production became increasingly based on computer-assisted controls. The fourth industrial revolution is still a vision. Experts believe that it will only become a reality within the next 20 years. In intelligent factories, everything is interconnected wirelessly. At the German Research Center for Artificial Intelligence in Kaiserslautern, this future can already be experienced right now. Research is underway here into exactly what the industrial production of tomorrow will be like.
Fabriken werden zukünftig aus Bausteinen bestehen, aus smarten oder intelligenten Bausteinen, wie man es nennen mag. Vergleichen wir das vielleicht mal so ein bisschen mit einer Lego-Steinwelt. Das heißt, wir haben standardisierte Bausteine, die wir hoffentlich relativ einfach zusammenstecken und zusammensetzen können. Jeder dieser Bausteine hat bestimmte Funktionalitäten und wir können sie zukünftig in einem solchen fabrikinternen Internet dann kombinieren.
A bottling plant for liquids, set up together with Siemens, is used to demonstrate the most important components of the intelligent factory of the future. Each bottle contains an RFID chip storing a precise description of how it has to be processed. Which liquid, which lid, and which label. At each station, the bottle communicates directly with the machine, telling it how it has to be processed. At the end, a computer checks whether the bottle has actually been produced as desired. Factories with networked machines and products are already in existence today. In the future, however, these hitherto self-contained systems will be connected together in a comprehensive network. All devices, machines, and materials will be duly equipped with sensors and communications technology and connect to each other. These systems are known as cyber-physical systems. The highlight is that they communicate with each other and also control each other cooperatively.
Wenn Sie sich das Thema Industrie 4.0 angucken, dann basiert sie ja auf der Logik dieser Cyber-Physical Systems. Das heißt, Sie haben autokrate, selbst arbeitende Systeme, die sich optimieren und sich gegenseitig austauschen. Und dadurch letzten Endes Produktion optimieren.
Ja, die Vision sieht so aus, dass wir ein Internet quasi hinunterziehen bis auf die unterste Ebene. Das heißt, jeder Sensor, jeder Aktor wäre damit quasi ein Teilnehmer eines Internet der Dinge. Jedes Gerät hat damit eine eigene IP-Adresse, ist damit adressierbar in diesem Netzwerk.
For the customers, this means tailor-made products at relatively affordable prices. For industry, it means highly flexible mass production that can be rapidly adapted to market changes, because in the future, product life cycles will be even shorter. Another reason why it's increasingly important to depict engineering across the entire life cycle. Maintenance, for instance, is planned in from the very start.
Wir haben ja bereits in den 90er Jahren mit Totally Integrated Automation entsprechend ein Setup gewählt, wo unsere Produkte und Systeme sehr gut miteinander kommunizieren können.
At Corporate Technology in Princeton, a cyber-physical control is being researched even today. The vision, the control, and all linked sensors are connected to the internet.
One potential scenario is enabling the PLC to react to utility pricing information in building automation. We can enhance PLCs to use simulation to calculate how much to pre-cool a building, with the ultimate goal of turning off the cooling system during peak times.
But that's just the beginning.
We've prototyped capabilities in a PLC to access big data in cyberspace in real time. And we've also enabled a network of PLCs to connect to a dynamic simulation of the entire physical process.
Siemens is shaping the future of industry. Connecting the real with the virtual world of production is making it possible to enter entirely new dimensions in quality, efficiency, and flexibility. The company is well prepared for Industry 4.0.
So class, my question is कि ठीक है, आपने ये वीडियो देख लिया? You all have seen this video. Was there any issue regarding buffering or audio? Please confirm on chat box. Was there issue or not? You can write no issue, or if there was an issue, you can write issue. No, okay. Okay. Now tell me what you understood with this video. I need answer from everyone. Ritik, Nayan, Shubham, Hitesh, Khushbu, Sachin, everyone. I need answer from everyone. You have seen this video and you need to give answers. Answers, class. Am I audible? Yes. Okay. In this video, okay, let me shortcut the questions. In this video, were they talking about Industry 3 or Industry 4? Yes. Industry 4, Industry 4, Industry 4, Industry 4, Industry 4. Industry 4. Okay. So are you going to enter into, you all are going to enter into industries, okay? And after few years you might be an assistant manager or a general manager at a very good post in industries, right? Okay. So are you going to deal with industry 3 or industry 4 at that point of time, irrespective of location? If you are in India or outside India, it doesn't matter. Yes, you will be dealing with industry 3, and you might be, or you will be going to be the one who is going to integrate industry 4 with industry 3. And what is the core of industry 3, as you have seen in this video? What was the core into this sector of industry 3? Yes, IT and electronics. See, okay, okay. Okay, now let me just tell you one thing. You all are fascinated by robotics. I am just going to provide you a very harsh truth that you are interested in robotics because there is coding involved in it. Am I correct? Because there is control involved with it. Am I correct or not? You might accept it or not, but there is some where feeling inside you that you should be connected to some kind of software or some type of coding or something else. But the most important and good thing about it is, from this video I wanted to show you that internet is coming on the shop floor now. Okay, so now on the shop floor, when you know about the shop floor competency, internet will be there for you, and you are going to extract that data. But once you are compatible with the shop floor, then this is going to help you a lot. Okay, now you have seen in this video that industry 3 is much more important, and now we are integrating industry 4 with industry 3. Someone has mentioned IoT. What is IoT's full form? Can you please tell me? Just unmute yourself and answer the question. What is IoT? What is IoT, class? Someone had mentioned IoT. Yeah, Ritik.
Controlling devices with the help of internet.
Internet of Things. Yes, Shubham and Ritik. Thank you for your response. Thank you very much. Internet of Things. What does that Internet of Things means? See, I am just going to introduce with the aspect of Internet of Things to you. Okay, we are not going to go into the details. I am just here to tell you the importance of Industry 3. Unless you are not compatible with Industry 3, you will not be comfortable to integrate Industry 4 with the existing system. When you don't know that how a PLC work, how, even if it is a mechanical component, even if it is a pneumatic component, even if it is an electrical component, how it is integrated to a system, how PLC controls it, how a very simple process works through PLC. If you are not going to understand that, then tell me that how you are going to deal with industry 3 or industry 4. Okay, so most importantly, this session is for to let you know about the importance of factory automation, that why factory automation is important, and about Internet of Things. Let me tell you that how much important it is now. In 2003, in 2003, how much for per person human is on internet? We all have internet right now. Am I correct or not? We all have internet or not? Yes. And can anyone tell me that what is world population right now? About 8 billion, about 7 billion. Let me assume that all the 7 billion people, around 738, you can say 7.38 or 8, around 7 or 8 billion approx. So this much of people are on internet. Okay, this much of people are on internet. Do you know how much things are now integrated with internet? How much things are integrated by internet? Do you know? The number is 50 billion. Can you imagine? The number is 50 billion. So you can understand the importance that how the industries are transforming, but they are not. It doesn't mean that industry 3 had lost its relevance. Okay, you see cars running through mechanical. In industries, you are always going to see gears, you are always going to see hydraulic components, mechanical component, electric motors with change of design. But you need to understand that how all these technologies are integrated into a single system, factory automation. Okay, and now you know that from for Internet of Things, you can see there are only 8 billion people maximum that are on internet, but there are 50 billion things on internet connected right now, and that was the data for 2020, and it is increasing exponentially. Okay, so you know the relevance. It is important for you to understand the relevance of, you can say that how industry 3 is transforming into industry 4, but industry 4 is taking the help of industry 3 only. If you are not going to understand this, um, now you just understand this, that if you are cognizant with industry 3 concepts, you know that how to integrate things with PLC. Okay, the only thing that you need to know is that how you need to integrate PLC with. For industry 4, what you are doing, simply what you are doing, you always connect your sensors or your actuators to PLC in industries, right? We talked about it, that in industry PLC is the most important thing because it is rugged, because it is reliable, and it is robust. Okay, but all the actuators and all the sensors in any industry are integrated to, even robots are integrated to what? I need an answer, please. All sensors, actuators, robots, whether they are robot, whether there is a conveyor belt, all are integrated to what? All are controlled by what? Kindly answer the question, class. Answer the question, class, please. Just a 3-letter word. PLC. The answer is PLC. So if you know how to integrate a mechanical system with PLC, then your only job that will be left, and which is getting transformed day by day. Yeah, you don't know where it will be going, that how you are going to change it. By the span of time, you will be getting to know that how you are going to introduce to industry 4. Yes, a glimpse of that will be provided to you, but the main motive is that if you are not cognizant with industry 3, then how are you going to be cognizant with industry 4? Because if you are not knowing that how PLC is integrated to a component, first you have to understand that how PLC is integrated to sensors and actuator. Then you need to understand that how PLC is connected to. For industry 4, what is happening? In industry 3, the components or the shop floor were connected to PLC, and PLC was connected to SCADA, which is a central computer system. Now what will happen? PLC will be connected directly to what? Any answer will work. Please answer. Any kind of answer. In industry 3, yes, internet. Your PLC is going to just getting connected to internet. Okay, for that you are going to get a very different system, and once you know that how data is generated in PLC, how you control a particular system with PLC, you are going to very easily connect to that how that data is to be transferred to internet and how you can get information from the data, and that will be your learning path. But the stepping stone for the learning path in factory automation is going to be the industry 3 concept, that is how to integrate a PLC with your sensors and actuators, how you integrate a particular process, how a process works, how you define a process in industry. Until and unless you don't know how to define a process in industry, you will be stuck in shop floor only. And trust me, when you go to industry, you are not going to get all these details because the system is continuously working. And you are never going to get a dedicated system where you can you can speculate that how the system is integrated to PLC and how you control it. A very good opportunity for you is that you can learn how a system is integrated in a single platform, and how all these systems are integrated into a single platform and controlled through PLC. Okay, so this is the SOP for factory automation. Plus, you are going to get the concepts of robotics also, that how a robotic arm works and how you are going to teach a robotic arm. So what we are going to do is, we have seen the learning path. In factory automation, we are going to look into that only, about the basic of robotics, about the basic of factory automation. And in fact, in factory automation, we are going to deal with how a system is integrated. Now, in factory automation, if you know that how a system is integrated, so what is the class of engineering that deals with the integration of system? Can you tell me? In engineering, you learn the class of system which deals with the integration of system. That is mechatronics. Am I correct or no? You kindly respond. Yes or no. Answer should be in yes or no. Am I correct or not? I need 18 answers now. Yes or no? सो गए बेटा सारे. Okay, Shubham, you have any doubt? If you have any doubt, please ask. Feel free to ask. What doubt it is? What I am saying is that it is very important for you to understand it, how all the systems are integrated into each other, and mechatronics is the class that you are going to that is going to give you the answers. Okay, so just for a very simple line, I am saying that you have a feeder station, where, or you have a lifting station in industry. There is a 5 ton of role that you need to lift. Okay, so I need answer from all of you. How you are going to make a system that lifts a 5 ton of roll? Not from you need to lift it from the ground up to say half meter, 500 mm. You just need to lift a roll 500 mm. What you need? What kind of system do you need? Shubham Kumar answered hydraulic. Very good. I need answer from all of you, whether it is right, whether it is wrong. I need answers only. Okay. Sahil, what is your answer? Sahil Gupta, what is your answer? Well, no idea. Just even if you want to throw a fluke, you can throw. If you want to lift a 5 ton roll, what kind of system do you want? Any kind of answer will work, except no idea. This is the only interactive class that you are going to get. So please. Cranes, okay. Nayan Arora, Hitesh, magnetic force. Pulley, yes. The question might sound a little bit mechanical, but the electrical and electronic part is going to come now after this. So please answer this question quickly so that I can just cover all the aspects. Please. Nayan Arora, Hitesh, Khushbu Kumari, Sachin Kumar, Kalpana Singh, Hitinder, Ritik, please kindly respond. At least respond. Even if it is a fluke, at least try. Cranes, hydraulic. And who else is there? Abhay Kumar, Adarsh Shukla, Ankush Singh, Aprajita Kumari, Bhanu had answered. Uh, Muskan Jindal, Nayan Arora, Raj Nandini, Ritik Sethi, Sachin Kumar. Respond, kindly respond it. But it is a very simple question. Or you can say not even simple, you can answer anything. Yes. So now you can see hydraulic can be the option, pulley can be the option, crane can be the option. Someone has said that even magnetic force we can use. Yes, of course we can use, but we need to control this system also. What I said was that we need to lift it only by 500 mm and the weight is 5 ton. So normally you use hydraulics for such kind of weight because it give you a very accurate movement. You can also use cranes, but for crane stability is always a issue. For pulley also, pulley is an example of crane only. Okay, so let us take an example of crane, okay, or even hydraulic. Both examples, we can take the example of cranes and hydraulic. Now just tell me that when you are using crane, what kind of energy is converting into what kind of energy? Class, please respond. Kindly respond. What kind of energy will be transformed into what kind of energy? Potential to kinetic. I'm just yeah. Potential to kinetic. It can be, but what kind of potential is there? Thank you for responding. At least a few of you are responding. Okay. Okay. Thank you for responding. You are all. The response is highly appreciated. You have tried, and very good that you tried mechanical to kinetic energy. Now, just tell me that when you are lifting a roll of 5 ton, you are using hoist to lift. Okay. So you can say that a mechanical energy is transformed into kinetic energy. And from where that mechanical energy came to gravitational potential energy. Now, see, your mechanical energy was coming from rotor because there would be a pulley attached to it. That pulley might have been rotating, and that pulley rotated, and you have got the elevation to a particular roll. Now you know that your mechanical energy was converted into gravitational potential energy because it was lifted to a certain level. But have you thought about it that from where that mechanical energy came for that single crane system? That mechanical energy came from a rotor, and rotor was connected to a motor, and motor was which kind of energy? Electrical energy. So now you know that electrical energy converted into mechanical energy, and mechanical energy converted into gravitational potential energy. Okay. Now it has to be controlled. It has to be controlled. The lifting was 500 mm, and it was required to control that the motor should stop at 500 mm. For that, what you will use? For that, what you will use? You will use a sensor. You will use a controller, but you have to sense that whether it is 500 mm or not. For that, you need a sensor, and sensor needs energy. What kind of energy does a sensor needs? It needs electrical energy. Okay, it will need electrical energy. Okay, sensor will provide an output to the controller, and now what controller needs? Electrical energy. Okay, and now see, the controlling energy was electrical energy. Okay, for that control you need an excitation, and that excitation was electrical. For initial you need an electrical energy. Electrical was converted into mechanical, and mechanical was again converted into gravitational potential energy. Okay, now again let us look at the another option of hydraulic. Okay, now you have a hydraulic system. Now, in light to crane that I have told you, can you define me that what will be the system for hydraulic energy? For hydraulic system for lifting a load of 5 ton? Okay, just tell me that how the energy will flow from you can say that hydraulic to electrical to mechanical, electrical to hydraulic to mechanical, just like this. Only three energies involved, three big scope of energies. I need answers from everyone. Please kindly respond. Electrical to hydraulic to mechanical. Very good, Ritik. Thank you very much. Yeah, this kind of answer is very creative. Respond now. Ritik had helped you all. You can just answer it in just three or you can say six steps. Electrical, mechanical, potential, electric, hydraulic, mechanical, electrical, hydraulic, mechanical. EHM, EHM, EHM. Yes, EHM is correct. Correct. Shubham, electrical will be converted into mechanical into potential. Yes, but you can be more specific about hydraulic. Hydraulic is more flow-based energy system. Okay, so now you can see that how many different kind of energies are required to control a system. And if you have a very simple system in front of you, you can understand that how it is changing each and every aspect. Understood? So you can see different kind of energies are involved, different kind of controls are involved. Okay, okay. Now you know that when you are going to lift a hydraulic system through hydraulic system, the flow will change its direction in order to stop or in order to move forward. Okay, that again will be controlled by whether it will be controlled by sensor or actuator. Will that be a system of sensing or actuating? For example, that you just need to lift up to a particular position, and when it will be stopping, you can just get into your mind that the flow of hydraulic will change. Okay, so whether it will be a actuation process or sensing process. Maybe both. Sensing, sensing. Actually, it will be an actuation process. Why? Because you are changing a particular direction. You are not sensing it. I was just discussing about the process when it is going to move forward and hold. That will be only dependent on only is a class of actuation only. It is not a class of what you can say sensing. Yes, sensing will be there is a sensor, it will read the position and it will give an electrical signal. Now let us just look at the complete, because what you have seen into your theory books. Why I am telling you this? Because you need to have practical examples for that. Since I have seen in your books also, in books what you see is you see a open loop control system, you see a closed loop control system. There is a just a very single system that has been seen in your books, that it will sense something, it will provide output to something and it will be done. But when you come to a integrated system, the things get complicated. So when you sense a particular thing, to whom you are giving that particular signal? Are you giving this signal directly to the actuator? Tell me that, for example, in this particular example, if there is a sensor for position, are you directly going to give that, for example, say 24 volts are generated when the lift is reached to the 500 mm position. So that 24 volt will be directly given to the hydraulic system? No, it will be provided first to a controller, which you can see here, it is PLC, programmable logic controller. It will create a certain logic that will work according to the process. And now see, if PLC has got a 24 volt input and PLC will give a certain amount of output, so can 24 volt lead to that much power that it can stop a 5-ton roll? Can 24 volt can give? No, it cannot. There will be a system. Okay. And in your books, what it is written, from the feedback, it directly goes to actuation or to the controller through actuation. There is a set entire, you can say, mesh of components that from where to what it is going to deal with, and that is factory automation. And that is a very important concept that you need to know when you are going to answer these questions in your interviews. You are definitely going to get prioritized. Okay, because this is something that industry is looking for. This is the big fish into industries. This is something that industry try to thrive, that whether students know how to read the process that is working. When you will demonstrate that you know how a process works, how a process integrated, along with robotics, that how a robot is integrated to factory automation, they will not choose, they will only choose, for example, if there are 100 jobs of mechanical, irrespective of branch, whether it is mechanical, electronics, or electrical, when you are in core engineering, there are 100 jobs. Trust me, there are 90% jobs related to factory automation or shop floor automation. Shop floor doesn't mean you are an engineer. For shop floor, it doesn't mean that you have to go and work on those. You need to analyze that. If that system fails, you need to understand that how that system works. Understood? You will be answerable to the questions. And trust me, if you are thinking that you are from electronics department, you don't have to answer that. I was in industry. I was at UAE, Ras Al Khaimah. Irrespective, I've also worked in mechanical industries, and I have worked with electronic engineers also. One of my friend was a GET when I was a GET there at Ras Al Khaimah, UAE. We both were recruited from NIT Bhopal campus. We both were friends, and we have to deal with the same kind of answers, irrespective of branches. When the system breakdown happens, you are answerable to few questions. But if you don't know about the system, you are not definitely not going to understand what is written in the manual until and unless you don't know how the integration is. This is my self experience. Irrespective of the branch, it is very necessary for you to understand that how the factory is automated by integration of system. You might be listening from your friends that full stack developers are required in CS department, right? Most of people say that you need full stack developer. But trust me, in manufacturing sector, now there is an increasing demand of full stack engineer who know how a process is integrated. That doesn't mean that you need to learn all the aspect of mechanical, all the aspect of electrical. It will be fun. Okay, it will be a kind of learning that will be fun. I will be teaching you about the system integration, and I will be very much precise about other concept, and I understand your background is from electronics. So I will not go deep into all the concepts. I will just go into the concepts that are important for you to understand that what factory automation is. Okay. So are we aligned to this now? This session was mainly for to introduce you with the program that we are going to run and getting you aligned with this particular program. So just kindly respond with it that are you aligned with it? Now I need all the answers. Okay. 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 So okay. So for today, let us just finish till here only. And it was very good talking to you. If you have any query, just one more introduction I need from all of you. Please unmute yourself one by one. Just one more introduction type. Okay. So I will just call the name, and because you will not ask any query, if I will ask for all the people, there are only 18 students. Let us communicate. Let us make a group that we are not confined to only this particular topic. Okay, we need an overall knowledge, and then sky is the limit. Okay, a very good and communicated group is the key to perform. Okay, even if you are not confident to connect, kindly take this as an opportunity that in this group you are going to connect to everyone. Everyone is equal. I can learn from you, you can learn from me. Everyone has a different sort of knowledge. Let us share it on a common platform. Okay. So just one by one, if you have any query or you need to answer something, you need to say something, you are very much welcome. So I will just start with Abhay Kumar. Please unmute yourself.
Hello,
Hello, Abhay.
I'm Abhay. Hello, sir.
Huh.
Hello, everyone. I'm Abhay Kumar. Uh,
Yeah.
yes, I want to ask a question. I
Yeah.
have doubt, sir.
Yeah.
What type of programming we do in PLC?
PLC has
Uh,
ladder logic and functional block diagram.
okay, sir.
And your robotics will conclude different kind of programming that will be covered by Mr. Ajay. Okay.
Okay, sir.
And in fact, in ladder logic and FBD itself is a very big C. You might have just seen very simple logics, but when you can say functional block diagram, or you can say data block, organization block. Do you know what is data block? What is organization block? How timer and counters work? Do you know that, Abhay?
No, sir.
Yeah, when these things come into picture, na, ended, what is the difference between simple ladder logic and actual ladder logic? Okay,
Okay, sir.
anything else you want to say?
No, sir.
Okay, thank you. Now, Adarsh Shukla. Adarsh Shukla.
Sir, I don't have many. Hello.
Hello, yeah, Adarsh. Yes, Adarsh.
Yes, sir. Sir, in today's lecture,
You are
I
not.
don't have any. But when things came to hello,
You
hello.
can respond on chat box also. If your voice is not clear, you can respond on chat box also. No issues.
Okay.
And let us communicate and understand we can help each other into that. That is very important. It is very important for communicate, because when you communicate in a group, you get a very different type of confidence, and that confidence is very much necessary for industries right now. It is okay that you don't know something at an initial level, and if you communicate that yes, I don't know this, you will see the change, that when you will be not hesitating about saying this, that I don't know this, you will see a change when you work in industries, or even at this point of time also. So just never hesitate to ask questions, whether it is, even if I don't know, I will not be uh, I will be trying to looking for that particular answer. It can be tough, it can be stupid. If you sound, no question is stupid actually, but it might sound stupid, but ask that question. Okay. When things come to mechanical part like hydraulic, it is similar because things are new. Don't worry, Adarsh. I will be taking care of each and everything. Okay, I will be providing you detail about. I think most of you have. I think Shubham Kumar has taken my lecture on pneumatics also, but I am not going to go so much deep into pneumatics and hydraulics, but a very fun part, that how it is connected, how you connect a particular sensor in a very fun manner. And if you have any query, you can always come back to me. I'm always there for you. Okay. And it is not such that you will have a very what I say, that you will be asked heavy questions about that or something like that. There is no issue. You just need to understand the physics behind it, or you can say the basic nature about hydraulic. This course will be more, if it is not aligned with electronics and electronics, then it will be more about the nature, that how it works. You need to focus on how it works and how it is shown in industries. Right now it is very easy for you to say and skip it, that I am not interested in mechanical part like hydraulic. Okay, now just I am going to give you an example, that suppose portray a picture that you are a assistant manager, or at the shop floor, and from electronics background. Okay, there is a circuit, and there is an electronic control to it, and it senses a particular part and it actuates, and there is a solenoid coil that shifts the hydraulic valve in a particular direction, and that solenoid valve is not working. What will you look first? You will first look at the manual of the system, of the process, that where that hydraulic coil is integrated, from where that signal is gone. Can you answer that question without understanding that how it is interrelated to each other? Can you answer? Just answer me yes or no. If you don't know how it is integrated to a hydraulic map, can you answer that? No. No, right? So you understand that how much important it is, and it is not rocket science. It is not that much tough. If you will enjoy it and just see it, that how it is going to integrate with each other, it will be very easy for you at that GT level. Okay, and it is very important for you to understand that when you go into GET, if you know these kind of things, now you get a very different type of impression at the early stage of your life, and that is very much important. Okay, I'm not saying that all of you will be getting a job that will be connected to related to pure factory automation, but I am very sure that most of you are going to touch it in some way or another. And when you are going to deal with robotics, you are definitely going to touch it, because for robotics specific industries are very much less, but for factory automation, entire manufacturing sector is there for you. And you can't say that manufacturing sector is small. You have big companies working on it. Okay, so whether it is Reliance, whether it is any PSU, whether it is what you say, any kind of PSU, whether it is Reliance, whether it is you can say Adani, even in construction, every kind of manufacturing sector, even construction sector, process sector, now also medical sector. Every company related to technical aspect is going to uh, be related to this kind of job. Okay, so I'm not saying out of 18 students might be mostly I can say that more than 60% of you are going to touch factory automation. And if you do it, if you are master in factory automation, you are going to love it. And I can definitely say that all 18 of you will touch it. Okay, this is something that you need to understand. Adarsh Shukla is done, I think. Ankush, are you there, Ankush?
Hello.
Yeah, Ankush.
So I have no query.
Okay, you have no query. Okay. Okay, so you can at least say hello to everyone.
Hello, everyone.
That's good. It's good that you need to communicate. Yes, Aparajita Kumari. Aparajita, you have an audio issue? Okay, no issue. Do you have any query? If you don't have any query, just say, yeah, yes, continue. Okay, if you don't have any query, just answer hello everyone. Yeah. Bhanu? Bhanu? Bhanu?
Hello everyone. Hello sir.
Yeah, hello Bhanu.
Hello.
Yeah, hello.
Yes sir. Whatever you have, I think I just got it. Just I was confused with one term
Yeah.
that again and again. The factory automation. So can you elaborate it more? What exactly it is?
Okay. Okay. Thank you very much for asking this question. It is a very good question that if I have not got you on factory automation. See, you have seen that video, right? Okay. So till industry 2, what happened was there were only electrical instruments, or you can say electrically supplied machines that were working, but they were not automated. What that means to say that the logic was only based on relays. Okay, so for example, there was only switching based logic. There was no such thing called as controller, which has the single chip. Now just look at the scenario. If you need to control 5 processes through relay logic, what will be the electrical diagram for that? You need to pass, every time you need to pass a wire through a relay, then bypass it to another relay, then bypass it to another relay. That will be a very complex situation for you to control. Okay, but by the introduction of factory automation, you have a controller dedicatedly, a very robust, a very reliable, and a very repeatable controller, which is PLC for that, which you are controlling an entire process through that. And also you are getting the exact accuracy, repeatability of a single process. Okay, so factory automation is a branch that deals with the automation of factory in terms of controlling a process through a processor which is rugged, reliable, and repetitive, known as PLC. ठीक है भानु? If you have any other doubt, I will get back to you on that separately. I think most of the situation
Okay,
is
thank you,
clear.
sir.
Okay, Hitender.
Yes, hello, sir. Hello, everyone.
Hello, Hitender.
Yes, sir. I have no queries also.
Okay. Hitesh.
Hello, sir.
Hello, Hitesh.
Hello, everyone. Sir, no query, sir.
Okay. Kalpana Singh. Kalpana Singh. Khushbu Kumari.
Yes, sir. Hello. Sir, no queries for now. And hello, everyone.
Hello?
Yeah, Kalpana Singh.
Sir, no queries.
Okay. At least say hello to everyone.
Hello, everyone.
Muskan Jindal. Muskan Jindal.
Hello everyone. Sir, today's class I have no queries.
Okay. Nayan Arora. Hello, Nayan. No, IoT will not be the part, but if you want, I will take a session related to IoT, that what IoT is, how IoT is going to get integrated through PLC. I can take that part. We don't have hardware related to it, since that hardware is very much costly and it is not being even procured by most of the industries right now. You have to deal with it for when the value is very much costly. But how it is attached and how industry 3 is going to get transformed into industry 4, yes, I will take that part. Raj Nandini.
Hello, sir. Hello, everyone. Sir, I have no queries in this session.
Okay. Ritik Sethi, you
Hello.
definitely must have queries.
Sir, not in today's session, but in a general.
Yeah.
Means, will there be any kind of simulations, or we will be going to NIT for performing this project?
You will have very preliminary simulations on ladder logic, a very basic about Siemens TIA portal. See, your PLC is going to get connected through a, you can say, what you say, interface. Okay.
Yes, sir.
So that will be Siemens TIA portal. Okay. Here we have a PLC sim which simulate the entire process. Okay.
Yes, sir.
And we have a dedicated automation lab where you will go. There are dedicated PLC where you can program it and you can see how the logic works. You have toggle switches there, so you can play with the uh, logics there. Okay.
Yes.
Okay. So you are, yes, definitely you are going to see the simulation. In my first introduction to mechatronics session, few students have seen that I have introduced TIA portal, ladder logic there, and also I have introduced fluid sim. But I am not going to cover fluid sim because that is much more mechanical and not related to electronics people. So I will just not introduce that fluid sim part, which is of simulation of pneumatic parts, but that I will not cover. But yes, Siemens TIA portal, I will give you a just brief so that you can be launched to PLC programming, which is a specific session which will be taken by Automation Lab by Suraj sir. Okay.
And sir, there would be only one programming thing. Means just we'll be programming the PLC.
You will be programming the PLC and you will be teaching the robot in separately in robotics lab.
Okay, sir.
Okay. PLC programming, you will be learning about PLC, and in robotics lab, you are going to learn the teaching of robots.
Okay, sir.
Okay. You have the dedicated session for robotics also, right? Okay.
Yes.
Any other doubt?
No, thank you, sir.
Okay, thank you. Thank you, Ritik. Sachin Kumar.
Yes, sir. Hello, sir. Hello, everyone.
Sachin, you were in mechatronics also, right?
Yes, sir.
Yeah.
Sir, I have one query regarding ongoing program.
Yeah.
Sir, is it confirmed we will have to join college from 21st February?
Sorry, you were not audible. Can you repeat the question? Or you can write it in the chat box.
Is it confirmed we will?
Your voice is
confirmed
not,
we will have from.
Sachin, your voice is not clear. I regret to say that. You can just put your query in the chat box. I will answer that. Okay. Just you put that in the end. I will answer that. Sachin. Let us move to Sahil Gupta. Sahil.
Yes, sir. So I have a query. Like you said, a robotic arm is a part of factory automation. So
Yes.
What are the other parts which compute factory automation?
Right, in the next session, yes, you will get the answers of all these. That what are the other parts? The other parts are basically PLC, a conveyor line, all the components that are integrated with a particular production line. The entire production line is a part of factory automation. Robotics is just a part of it. So it has, you can say, pneumatic systems, hydraulic systems, mechanical systems, electrical systems. You have pumps, you have flow lines. Everything is related to factory automation only. Everything is interconnected to each other, right? When robot will perform an operation, when a robot will perform an operation, when a you can say job is there in front of the robotic arm, and when there will be a robotic arm, it will be a job will be in front of it when the conveyor will move. Okay, so there will be a job, there will be an assembly line, there will be n number of components that will be related to it. Okay, sir.
Okay, sir. Yes.
Okay, Shubham Kumar. Thank you, sir.
Hello, sir. Hello, everyone. Sir, no doubt, sir.
Okay, Sunidhi Sinha.
Yes, sir. Hello, everyone. No doubt for today.
Varun Kumar.
Hello, sir. No queries, sir, for today's session, and hello, everyone.
Okay. Sachin, it is not confirmed yet. We don't know about that. That you have to join college from 21st February or not. It is not confirmed till now. So let us just see what happens, because it is much more of a question to be answered from NIT side, not from our side. We will be informed if you are going to join college. Till now, we only have that information that you have 90 hours online session that we are going to cover. Plus, you have an 18-hour session with the robotics lab also. Okay. Chances, I don't know. Chances might be there. Chances because vaccination is coming into picture. Yeah, there might be chances because we are at Siemens Center of Excellence from July 2020, and we have seen that students are now coming to the campus. So you might be called. MTech, I think, are called. PhD students are called. So I would like to complete the session now. I think everyone is done introducing himself or herself. If someone is left, please, you are welcome to introduce yourself. Let me introduce myself once again. I am Anuj Sharma, and I am the in charge here at Mechatronics Lab. And for this particular course, I will be teaching you factory automation, about the introduction of factory automation and basics of robotics. Okay. Thank you, everyone. Shall we conclude the session now? Thank you. See you tomorrow. One more thing. Please, one more thing. On 21st of Jan, I am occupied during 2 to 5. So that session on 21st, that session will be on at 10. Okay, so from 10 to 1 there will be class on 21st only, and that is only for one day because I am occupied in other belongings. Okay, is that fine? I will just also write it on 21st Jan. The session will be at 10 a.m. to 1. Okay, thank you, students. Thank you very much, and see you tomorrow.